Alright, in this last tutorial what we're going to do is we're going to concentrate on global illumination and radiosity with 3ds Max's rendering engine. We're also going to talk about modeling scenes to scale so it works correctly with radiosity solutions. Okay, what I'm going to do is I'm going to use the bedroom scene by default, obviously accepting the unit scale because we're dealing with actual real world units. And for this particular example, what I'm going to do, because we're going to use an internal lit scene, I'm going to hide the external lights, and I'm also going to kill the main sunlight coming in, because we obviously don't need that anymore. This entire scene is obviously modelled out to scale as a radiosity example as well. So if we have a look in the top viewport, what we've got, if I just pull up a tape measure, we've got things, for example, let me just change the snapping, and I'm going to put that back to 3D snap. We've basically got things modelled out to scale. For example, the length of the wardrobe is roughly set to about 279, 280 centimeters long. Excuse me. This was obviously taken from real world units because this is obviously, as I mentioned before, this is basically the bedroom, the top floor of my house. So therefore, a load of measurements were taken and it was modelled out roughly to scale. So any radiosity solution that we basically set within this scene is obviously going to turn out right. So what we're going to use is we're going to use standard IES lights. So standard photometric lights, and we can also incorporate additional IES lights if we need to. So in the actual room itself, we've basically got three actual spotlights, which are basically situated at the top of the room, roughly around about here, which basically throw three directions, one there, one there, one there. So what we'll do is we'll create three photometric lights and hopefully illuminate the scene and calculate the radiosity solution as well, so it looks relatively realistic. So we're also going to have colour bounce as well because of the floor and also because of the teapot as well, so we should get the correct colour cast as well. So first things first, let's just have a quick look at how this scene was created. Currently everything is set to group, so what I'm going to do just for safety is I'm just going to ungroup everything. So if we go to group, ungroup, and there's some nested groups in there, so I need to make sure that everything else is still ungrouped. So let's just select these guys. I'm going to select by name, just make sure we don't have any items which are actually grouped. No, we're okay, that's good. Okay, so the scene itself was created basically by standard polygon modeling techniques. The actual environment itself was just created by a basic box and then slicing and refining and so on. The knob handles obviously were created by, if I just go to the top viewport, started off with a single arc spline, which was then tweaked using an edit spline to deform it, and then lathed using a lathe modifier, basically just to swing it all the way around to create the basic shape. The drawers and cupboards were basically created roughly the same way. An initial profile was basically taken, which was then lofted around a specific shape, and then the top and rear surfaces were then capped. So we basically got a flat surface at the front, flat surface at the rear, and then the sides were basically chamfered a few times, just so that we've got this kind of nice curved edge. Same principle with the top of the shelf here. We started off with a rectangle, which was then, if I just go to turn show end results off. So we started off with a rectangle which basically had a corner radius, which was then tweaked to fit. So we basically got this flat edge here, which was then simply extruded and then in Edit Mesh I just chamfered the edges. This was created in an older version of Max, so therefore there wasn't an Edit Poly modifier. There's only an Edit Mesh one. So if you did this from scratch, you'd obviously want to use an Edit Poly one just to take the edges off. Okay, same principle with this guy down here and also down here. What this particular one was a virtually identical version. It was actually a direct copy of this particular lid here, which was then simply just sliced at the end, just to basically remove the detail. So if you notice here, we've actually got open faces, which we obviously don't want. So what I want to do here is I just want to cap those off. So we can literally just cap holes, and that will close the hole that the slice modifier is obviously generated. Okay, making sure all that's right. Yeah, that's cool. So I can then basically come out of the isolation mode as well. Let's just swing back around here. Just making sure that's all okay. Again, this side rail here, this side lid to this cupboard, this cabinet, same kind of principle. Started off with a rectangle, tweaked it, extruded, then using Edit Mesh I basically pulled this across and then sliced it at the edge where we didn't really need any extra depth. So as we've got a slice in there, what I obviously need to do, just holding to isolate the selection, just to bring it out, I'm basically holding down Alt and pressing Q, which isolates the current selection. So obviously we've got a hole at the back there, so that obviously needs to be capped off, otherwise the radiosity solution may create an issue or two. And because we've got a polygon, we've got like an edge which goes across there. If you notice, we don't actually have a joining edge. So what we've got here is we've got a numerous-sided polygon, so that might cause one or two little issues in the radiosity solution. So all I want to do is I just want to go into Edit Poly, and I just want to create an edge going from there to there, just to finish it off. And that's that fixed. Okay, the rest of it is, again, basic box modeling. And turn snap off as well, actually. Same principle with the rails along the edges. I mean, more than likely you'll have all this slot pretty much set in AutoCAD. So when you actually bring it into Max from AutoCAD using this guy, which is the import feature, you can basically bring in AutoCAD drawings, which is DWG and DXF files. There is a linking feature within Max, so you can actually link to the AutoCAD drawing. So it doesn't actually merge the entire thing; it actually references the DWG file. So therefore, if you decide to go back into AutoCAD, or if you're working with somebody else who's actually doing the AutoCAD drawing, and you're basically playing around with it in Max, if they update the DWG drawing, then it will automatically update in Max, because you're not actually physically merging it in. It's the same kind of principle how Xrefs work. Xrefs basically are externally referenced files, so other Max files which you can then reference in. It's a bit like merging, but you're not actually physically merging the actual object in. You're simply referencing it in another file. So if someone tweaks the scene in the reference file, so it tweaks the object, makes it, changes its properties, changes its characteristics or appearance, it will automatically update within your master scene, your main scene with everything in. Say for example this teapot was actually in another scene, it could then be tweaked a number of segments or radius, or have some deformation applied to it, that kind of thing. And then when you actually bring it in, you can basically you won't have the actual ability to tweak these properties yourself in the master scene. It will just say Xref details here, but because it's actually bringing it in as geometry, you can obviously tweak it using modifiers and so on. So you still have control, but anything that you make to it was obviously advised to use non-destructive modifiers. Okay, so the rest of the scene, like I say, is just simply box modeled, or by using lines to generate a shape, like for example, the floor itself kind of thing. It was basically just used to generate a shape and then extruded back. So I would draw the front end of the house, the front end of the room, and then literally extrude it back. And then all I've done is I've just literally cut a hole in there for there, extruded back for here, and cut holes and so on, just to accommodate the windows. But I've obviously created additional edges here so that when things are chamfered, it comes out cleanly, and when it's rendered, we don't get any like problem smoothing or anything like that. Okay, so with that in mind, what I'm going to do is I'm going to drag in a, let's have a look. What we'll use is we'll use a target point light to start with, and we can obviously change the type of light that we're obviously going to use at the end of the day. Actually, no, I think we'll use a target point to start with. So what I want to do is I'm just going to create a light that goes across in this direction, and then in the front viewport I'm going to move it up so it's near the ceiling. So I've got one face in that direction, and then I'm going to raise the target up as well. So I've got one light pointing in that direction. So we're going to get like a lot of light bounce in the scene. Okay. So what I'm also going to do, I'm going to turn off targeted now. Now I've actually got it pointing in the right direction, I'm going to turn off targeted. So what I can then do is I can literally just go to the top viewport. Let's just shift that across a touch. I'm going to rotate the light by holding down shift and rotate. I'm going to instance it. So I'm going to do one at 90 degrees. I'm going to move it slightly out like that, and then I'm going to do the same thing in the opposite direction by another 90 degrees, and move that as well. Then these guys, I'm just going to stick another 30 degrees on them so they're pointing at more random directions. So when we actually switch to the camera, if I just quickly render this for the minute, you can see the direction that these lights are starting to point. However, as they are obviously point lights at the present time, we're having some, blown out issues around this region. We've also noticed we've actually got a blue still present here, which is basically because of the environment color. So what I'm going to do is I'm just going to kill that, put that all the way down to black so it's night outside. Let's just re-render that. Just make sure we've got that. That's fine. So totally dark on the outside, and we're just doing an internally lit scene. Okay, obviously no shadows enabled at the present time. So what I want to do now is I want to basically change this to, I'm going to change it to an area light, I think, to start with. Let's go to perspective. Okay. And what we can do is, I think that we may change this to, let's just change it to a, there we go. So on the point light, we'll change the distribution for the minute. We'll change it to a spotlight. We can load in webs later on as we search for those through the Urco site in the tutorial in the workshop. We'll have a go at loading some of those in later on. But for the minute, we'll just try it with a spotlight and just see how we go for the minute. So let's just switch back to camera, render that out again. So we're now starting to get a bit of throw coming across here as well, so we're getting some nice displays on the ceiling. Obviously, we'd want to drop in the light fitting model in there, so I'm not going to do this in this particular tutorial, but in the final version, obviously, you'd want to merge in the light fittings as well. So, right, I think for this particular example, what I'm going to do is I'm going to leave the luminance values as is for the present time. We can tweak those later on if we need to, but for the minute I'm just going to enable shadow maps on these. Just do another quick test, and then what I'm going to do is I'm going to go into the advanced lighting radiosity. You're assigning radiosity. We need to assign a camera exposure, otherwise it's going to be way too dark. So would I like to change this? Yes, I would. So just ignoring radiosity for 1 second, what I'm going to do is I'm just going to scoot across to the radiosity, to the exposure. Now there are 3 main exposure controls. One is automatic, clues in the title. Another one is linear, and another one is logarithmic. Now, if we are doing a still, we can normally get away with using automatic exposure control. However, if you're doing an animation, you really need to use logarithmic. It doesn't necessarily yield the nicest results because you get some washed out areas, and the light areas don't seem as bright and the darks don't seem as dark, but we can always color correct that in Photoshop later on. But as we're just basically dealing with a still for the time being, we'll just deal with automatic exposure control. So with that, we can basically just switch to our shader view. You'll notice that we've got some like jagged areas across there. That's basically because of the actual geometry and the way it's actually being displayed in the viewport at the present time. So what I'm going to do is just do a quick render preview. Now you'll notice when I do that it says reflect refract, and that's not because we're actually using the reflect refract material, which is basically the bastard son of ray tracing. It's basically because of it uses part of the reflect refract technology to calculate the actual exposure. So we've got a rough idea of exposure in here. So if I rendered this out, it would obviously give like a slightly lighter result than before, which obviously we've got now. So obviously we've got like a bit of a harsh area across here because of the spotlight throw. So what we can do with that is change it later on for the IES or web lights. So for the minute, we'll just concentrate on getting the radiosity solution for this particular lighting setup, and then we'll sort out the webs in a second. So if I just switch back to advanced lighting to radiosity, what I want to do now is I just want to change the initial quality. I want to drop that down to about 30 just for previewing it, and then we're not going to bother refining anything. We're not going to bother meshing anything yet either. So what we'll do is we'll just do a quick basic radiosity solution and see what our basic result is. This might take a moment. So we've got a rough representation now of what the radiosity is going to look like. If I just turn off shader view, so we've got some like basic color bounce. We've got some cast from the walls, from the floor that's going across to the wardrobe and so on. So if we just quickly render this out, we can see the exposure and the rough representation of what's going to happen. Now obviously the radiosity solution isn't very accurate at the present time. Reason being is because we don't have that much geometry refinement in there. So obviously we need to go in now and refine the geometry. Now what Max can do is it can do it automatically based on the scene scale and also the meshing sizes. So again, as everything needs to be modeled to scale because we're using photometric lights, what we can do is we can basically use global subdivision, which basically gives us a few extra properties. Maximum mesh size is basically the maximum largest spacing between the meshing that it can deal with. The minimum mesh size is the smallest. So if we just go into our top viewport, if we pull in a tape measure for the minute, we can basically see roughly how wide we want the meshing to be. So we'd really want it to be, I mean, currently it's set to the minimum mesh size is 7.62 centimeters. So let's just see exactly how big that is in our scene. So it's roughly about that big. So it is quite small for the most part. However, it's not going to be small enough to deal with areas like this. We may get some blotching around this area to start with. So let's just start with these initial values initially, and we'll see how this turns out for the moment. So just using the default values, what I'm going to do is I'm basically going to reset, and then I'm going to start it again. Copy D. Obviously this takes a little bit longer, basically because it's now doing the refinement. So we've got a little bit more refinement in there, not a great deal. So let's just quickly render that out. Let's have a look, see if that makes any main difference. There's a slight amount of difference to it, but not a great deal. So what I want to do is I want to basically tweak the minimum mesh size. I'm going to drop that down to about 3. Take the maximum mesh size down. I'm going to take that down to about 20. Okay, I'm going to recalculate this. Let's just reset the entire lot. Possibly the reason it didn't work before is because I used reset, not reset all. Reset all resets the geometry, not just the radiosity solution as well. So we should get a lot nicer result now. Talk amongst yourselves for the minute. So we've got a lot more refinement in here now. That's basically because I didn't reset it all before, so my bad. So what we'll do is we'll have a quick look at what this looks like in the viewport. So we've got some nicer detail in here now, and I think what we need to do is we'll need to go through to the automatic exposure control. Let's do a quick preview in here so it recalculates it and we'll get an update. Here we go in the viewport. Obviously we can see some blotchiness and some stretching and everything around here. So what we need to do with that to try and smooth that out is we can go back to our radiosity tab and use the light filtering feature, which basically allows us to smooth out any direct. This is basically just tweaking the direct lighting, which is basically just the direct light coming straight off the throw of the spotlight. However, the indirect light filtering is obviously where it's bounced. So this is these guys here. So this is smoothing this out. It looks slightly jagged. Two reasons behind that. One is because of the geometry, and also because of the viewport configuration that I'm using to display, because I'm using the camera recording software, which is basically down here. Obviously I'm using the software mode at the moment, so we will get some kind of blotchiness in the viewport, but when we come to render it, it should look a lot cleaner. So I'm just going to put that up to 5, and then I'm going to render this out, and let's have a quick look to see what the result is like. So it's quite clean. We're getting a fair amount of light bouncing in there. However, we've got this pretty hard edge around the edge here because of the type of spotlight that we're obviously using. So I think at this particular time, what I'm going to do, because we're starting to get there with the exposure and the radiosity, I'm literally going to increase the exposure somewhat. I'm going to drop and increase that up. So we're starting to get some nicer intensity, and we're also starting to see the floor a lot more clearly now. So I think what I'll do is because all these lights are instanced, I'm going to go in and I'm going to load in a web file, and I'm just going to pull that across as well so we've got more real estate to play with. And I'm going to load in a standard, one of the standard photometric ones which comes with Max just for the moment. So let's grab in a let's bang in a, let's think about this. No, maybe not that one. Not necessarily that one either. So let's grab in. Let's try that. Let's see what this looks like. Obviously, if you're pulling them from the Urco site, you obviously know which particular one that you're going to use, but obviously I don't have that information in front of me at the moment, so I'm just going to go through and just recalculate the radiosity. So reset all. Actually, no, I don't need to reset the geometry, I just need to reset the radiosity solution. And start. Obviously bearing in mind that I'm currently only doing it with a preview quality, which is only set to 30. In the final version, what we'll do is we'll crank that up to about 80 or 90. So that'll give us a nicer result, a nicer amount of colour bleed and colour depth. So now what we should have when we come to render is we should have some nicer throws on the floor. Sorry, on the walls. We should get some nicer. There we go. We've got some nicer information around here now. So we're getting some stretching marks around this region here, which we obviously need to fix, and that's basically due to the actual geometry itself, like I say. So I think what I'm going to do at this particular point is I'm just going to clean up some of this geometry to basically get rid of that seam going down there. So let's just, I'm going to reset all, and then I'm going to extract this object, and then let's have a look to see what we can do to clean this up. So this is basically the main reason why we've got this problem. We've got a fair amount of cleanup to do in this particular region here. We've got an extruded area with a number of polygons that can basically be cleaned up around this particular point. So what I'm going to do is I'm simply going to, I think what I'll do is I'll just collapse that guy, grab that, collapse, do those ones in a second. So this is basically the negative aspect with using the actual radiosity solution. The reason being is because it actually bases the radiosity solution on Vertex Lighting. So that's the reason why your mesh can basically get absolutely massive. Pros and cons with it. One, it can result in a pretty nice result and renders out relatively fast. However, if your geometry is slightly over the shop like this was, then it can yield some pretty strange results as well. So what you really need to do is make sure that the geometry that comes in is pretty clean. Again, not really mixing quads and tris, so that's basically what I'm trying to clear up at the moment, or multiple sided objects. So I'm just going through and cleaning up the problem areas in the geometry. So that gives us a nicer result. Same deal down here. Just going to clean these up in the corners. The reason I'm rotating around is just to make sure that I don't have any other vertices on the other side of the geometry, or like over this side, selected by accident. So that's got that. Let's go across to the other side, see what this is like. Yeah, same principle as before. So I'm going to try and see whether or not I can use a weld to try and... No, it's not going to let me. It's okay, I'll do this by hand. If you've seen this before, you might want to fast forward through this bit. Not need to worry about this bit, basically because it is so small and it's not going to be very, very apparent in the final version, so we can get away with that. And then the last bits to sort out. That up there is relatively okay, so that's alright, that can stay as is. It's just this last area here. Okay, so when we calculate the radiosity solution now, it should, I'm just going to collapse those actually, just for safety. So and you need to go down. You and you. You and you. Right. So that's cleaned that up quite considerably. So that should, at the front now, we should remove any major streaking in there. So I've just come out of the isolation, go back to the camera, and because it's instant, obviously we've got that, which is also applied it to that side as well. So let's give that another go. I'm going to start that. So a lot of the time you're basically going to have to, with radiosity solutions, the downside to it is that it is a case of a lot of setting tweaking. You never normally get it right first time around, so it is a case of a lot of setting, tweaking, calculating the radiosity, making another tweak, calculating the radiosity, and so on. If you do have a large scene with a hell of a lot of assets in there, then you are going to have, it is going to take a long time to basically calculate it correctly. So hence, using the standard lighting, faking the global illumination with the color bounce and everything, it is advisable to go that way as well, basically because it can take less time overall. If you're up against it, calculating a radiosity solution isn't normally the best way to go. However, if you do have like a brute force method, like for example using light tracer or V-Ray, like I say V-Ray especially, it can basically calculate it at render time. So it basically goes through and works it out there and then. So you don't have to go around and start pissing around with all this lot. So let's have a quick look at what this looks like in the render. So now what we should have is this area fixed, which we do, which is good. We do have an issue down here, but I think for the most part we will leave that for the minute. So let's go and finalize this. I'm going to crank that up to 85%. We don't need to refine the objects because we're basically using the adaptive meshing. I'm going to drop the minimum mesh size down. I'm going to drop that down to 1 centimeter, so we get some nicer detail around these regions, and should get it around the base of the teapot and into the corner as well. And I think that should pretty much do it. Okay, and reset the geometry, and we'll give this a go. I'm going to pause this while it calculates it. I'll see you in a minute. Okay, the radiosity solution is now finished, and we can basically have a look at this. So we've got some nicer colour bleeding and colour depth around here, and some nicer refinements and nicer areas of illumination around these particular parts. So if we just render this out, we'll have a quick look at it. So we're getting some nicer colour depth and casting across. Obviously we've still got some of these seams which obviously need to be edited out in geometry, because we've got each edge is chamfered, so we've got like a line that's kind of going up here, so that would obviously need to be modelled out. But for the most part, for this example, it's okay. Okay, what I've basically done is I've taken the scene a little bit further. I've basically played around with the settings and come up with a nicer, cleaner result. So I'll just run through what I've basically done, because the result that we had before was okay, but we still had some like splodgy areas around this region and whatever. So what I've done is I've gone in and I've cleaned all that lot up. So I'll just run through the settings that I've used. So initial quality, we've used, what I basically did is I basically reset the entire radiosity solution and went through it from scratch. So the default initial quality set to 85%. What I've also done is I've refined all objects. So every single object in the scene has been refined twice by default before we even get down to the meshing parameters. We've kept the same settings which for the indirect light and direct light filtering, so we've got this nice smooth edging around here. Still using automatic exposure control, which is a little bit dark, which we can always blow up in a second. The adaptive subdivisions also used, which I've basically kept the maximum mesh size at a value of 10. By default it was something along the lines of about 30 odd. So I've dropped that down, the maximum meshing size to 10 and the minimum meshing size, so you get all this like fine detail around this region around here, is set to 2. Contact thresholds is kept the same, but what I've done, which I didn't do the first time round, was drop the initial meshing size, which is basically how globally it will do the meshing size to. I set that to 15 centimeters. So what we've got, if you just bear with me a second, it should hopefully display everything. If I turn on, this is basically the end result. So we've got a nicer, finer and even distribution of polygons here, courtesy of the double refinement and the iterations, and also because of the tighter meshing. So when we actually come out of that, if I just do a quick render, I've just done a quick render to preview, so this is exactly what you're going to get. So we've got one or two little issues around here, which that's basically due to geometry, but that's quite forgivable. We can basically go into the geometry if we need to and just clean that up. So the reason that's looking that way is if we just pull this up, the actual base polygons, this entire front area here is just a single face. So therefore, as we've got a lot of polygon edging around this region here, it's kind of stretching the mesh. Kind of like a similar problem that we had with the mesh smooth in the modeling example. Same kind of problem here with the smoothing. So therefore, what we need to do to clean this up is basically just go in and refine this front face, just to clean up, make quads out of the front of this little plinth here. Anything else that we need to do? Well, we can basically just go in and tweak the exposure. So let's just render a quick preview of that. And I'm going to turn off the meshing there. So we can then bring up exposure value, which will then do it in the viewport. So that's not looking too bad. Let's drop that down maybe a touch. And then we can render this out again. Just noticing we're still having the reflections in the teapot. That's starting to come out a lot nicer now. Carpet's a little bit on the dark side, but that's more than likely due to the actual type of material that's assigned. Don't forget that all radiosity in the scene is generated by not only the lights but also the type of materials that we use. The type of materials that we're actually using, there's a reflective one here, there's a slightly very glossy material for like the window ledge, and there's a little bit more glossy ones for the cupboard doors, but this area, these walls are quite matte, as is the floor, so there's not going to be a great deal of light bouncing coming off this surface, or the light that's actually the secondary light, because obviously it's bouncing off this wall onto the carpet. It's not going to be that very apparent, so what we might need to do is just bring up the glossiness values slightly on that. Additionally, this back wall here isn't receiving much light, so it might be worthwhile actually repositioning one of these lights and pointing it down to this particular region so it doesn't bounce around a lot more. And or put like a light that's actually behind camera just to illuminate the scene a little bit nicer. But apart from that, it's looking quite nice. There's not really many problem areas. The shadows are quite nice here, quite nice there as well. We've got a nice fall off from the webs, and I reckon that's roughly about it.